Okay, so the first thing we'll put on our blank page is the vocab that we just learned about converge and diverge. So converge would be when the sum of a series is finite. Diverge is when the sum of a series is infinite. Okay, I'm going to move on. Pause if you need more time. All right, so next, our focus today is on geometric series, and we're going to determine if a geometric series converges or diverges. So from the previous lesson, we learned about a geometric series. It would be in this form. This is our sigma, adding up all the terms from 0 to infinity. And then the A, just as a review, is the initial term. The R represents the common ratio. Which is the number you're multiplying by every time. And then N is what you would plug in for whichever term you're looking for. Now, to determine if a geometric series converges or diverges, well, if your common ratio, let's discuss this. Like if I had a common ratio that was like multiplying by 2 every time, that would make the series just get massive. It would be diverging. But if instead my series was multiplying by a fraction less than 1, so like multiplying by a half every time, then these numbers would actually become smaller and smaller. And when we would add these together, it would be finite. It would be converging. So it's dependent on our common ratio. If you're multiplying by a big number every time, like times 2, bigger than 1, that's going to make it diverge. It's going to be infinity. But if you're multiplying by a half every time, times a half, then that would be an example of converging. It's going to equal a finite, some constant number. So a geometric series converges if and only if your R value has to be smaller than 1, right? So multiplying by a fraction smaller than 1, then it will converge. You can actually have an R value that's negative. So I need to actually put here an absolute value on this. Like sometimes you might be multiplying by -1/2. And that's okay. As long as your value, whether it's positive or negative, is smaller than 1. So that's what we're going to be looking for. I'll also say AKA, which also known as. This is another way of saying your R value is between -1 and +1. As long as it's within that range, then we will have a converging geometric series. So all that will tell us by looking at this is if it converges or diverges. But if we wanted to know the actual sum of all infinite numbers on the converging series, I put converging because diverging the sum would be infinity. But converging, the constant, to figure out what that constant would be, has a little formula that we could use. So from the formula here, this is our general term. To calculate what this sum would actually equal is by doing this formula. A, which is our initial term, over 1 minus r. Very simple to plug into this formula. A is just your initial term, and r is your common ratio. And this will truly equal all infinite terms added together. I am going to just make a note here that this is the formula for when n starts at 0. So this is when n starts with n equals 0. Okay, so we just have to remember that it finds the sum of all the numbers starting with n equals 0. Okay, so let's get to some practice next.